protocols. I'm a network engineer with more than 20 years experience building enterprise networks and teaching people about them. Over the last 10 years, technology has moved from our desks to our pockets and has grown at an exponential rate. All this means we need talented IT professionals to keep data networks operating so we can surf the web on our smartphones and other devices. In this course, I will introduce you to the fundamental concepts of data networking operation, including IP addressing and subnetting, the OSI model, protocols and their port numbers, cloud computing concepts, and other foundational networking concepts and terms. By the end of this course, you will understand how clients and servers encapsulate messages to communicate with each other, as well as how to identify the major components of an IP version 4 and IP version 6 address. Since this is an introductory course, you only need an open mind and an interest in learning how data networks operate. This course is part of a 5-part series, and you should feel confident moving on to the second course of the series, Introduction to Enterprise Network Infrastructure, upon completing this course. I hope you'll join me on your journey to learn networking with the Network Concepts and Protocols course at Pluralsight. Hi everybody, I'm Ross Bagurtis and welcome to my course, Networking Concepts for the CompTIA Network Plus N10-008 exam. Now, this is the first course of 5 that will help prepare you for the CompTIA Network Plus exam. However, you do not need to be preparing for the exam in order to really appreciate these courses, because what we're going to do is introduce networking, talk about all of the critical terminology, and make sure you walk away from this course and the rest of them with a really solid understanding of data networks so that you can use that to both better your career or help understand what's happening inside of a data network better. Our goals for this module will first be to define what is data networking. And I really want to give us a foundation so that we understand what we're talking about here. Next, I want to talk about communication processes. I want to go through an example of using a smartphone to call a friend of yours so that we can see that there's a pretty complex system happening in order for that communication to occur. And then last, this is not for everybody, but if you are studying for the Network Plus exam, I'm going to review where you can download the exam objectives and follow along with those throughout these videos. If you're not taking the exam, don't worry about it. You can skip that part. So, what is data networking? And if I think about it in the most simple sense, if you've never really thought about what is data networking before, you might think of data networking as these devices in your house. These are cable modems. It could be a DSL modem. It could be a fiber optic modem. But these devices, typically anybody that has an internet connection is likely to have one of these devices in their house that they use to connect to the internet. So you might think of data networking as these devices. You likely have a device that looks similar to this as well. This is a wireless router, and this allows your smartphone, tablets, laptops, or other devices to communicate with the internet as well. However, networking is much bigger than just those home devices. Inside of a data center or a business or a networking closet, you may see some switches like this with lots of bundles of cables plugging into these devices in order to provide network connectivity. Not all of them are nice and neat and pretty like this one. Some of them get a lot messier like this one here, where it's just a bird's nest of wires, but both of these systems are doing the exact same thing, which is to provide networking to devices, typically in this case, in an office. So now that we've seen some devices and equipment that look like data networking, let's talk more about what it actually is, because that's just the gear to facilitate it. Data networking is actually more about transferring information. So here what I have is this is an icon of a server, and a server typically is connected to a network, and servers then hold data. And this particular server I'm imagining is the Wikipedia server, which contains an article on computer networks. And what I want to do as an end user is I want to go onto my PC over there on the left, type in wikipedia.org, and then do a search for computer networks. So I do that, and what I end up doing is I connect through the network, which I've represented as this cloud. And from this point forward, anytime we see this cloud icon, that means that there's some data network involved there. There's a bunch of switches and routers and wires and fiber optics and wireless that are all working together to transfer this information. And I represent it with a cloud here because it's much simpler when we're just trying to focus on certain aspects of this process. So I go on my computer, I search for that Wikipedia article. It gets to the Wikipedia server, and then the server transfers it to my computer so I can then read it. And this really is what data networking is all about. It's some version of this exact process. So what is data networking? It's a system of hardware, software, and protocols used to move information from one device to another. That's really the crux of it. This is really what data networking is. It's about moving information with a very specific set of software, hardware, and protocols. So let's introduce data networking and some of the processes we use here by talking about something that we do relatively often. Maybe not as often as we once did. Now we usually are texting our friends versus calling them. But let's just say here that in this example we have Leia over here on the left with her smartphone, and she wants to call her friend OB over on the right side of the screen to ask him for help. Well, in order to do that, there's all kinds of processes that are happening in order to facilitate this. But if we think about it in some very simple terms, in order for her to contact OB and ask him for help, she has to go on her smartphone, open up the phone app, find OB's contact, click on it. That will allow his phone to ring. He will answer it and say hello. She'll say hello. And now Leia can ask for some help. And what's going to happen here is Leia is going to start talking. And when she talks, that's going to vibrate the air. And that vibrating air is what carries our voice. Now, if OB were just sitting right next to Leia, he could just sit and listen to the air vibrate his own eardrum, and there would be no need for any other equipment. However, since he's on the other end of this phone, what's going to happen is Leia's voice is going to vibrate the microphone on her phone. And there's a little membrane in the microphone. It's going to vibrate that membrane, which is going to create a little electrical signal inside the phone. What the phone will do then is it'll take that electrical signal and it will convert it into a wireless signal that it can send up to the cell tower. Well, then the cell tower takes that wireless signal and it's going to convert it again. So now Leia's voice was encoded in this wireless signal. That encoded voice is then going to get translated into a signal that can travel across these wires on the telephone poles. They might be fiber optic, they might be copper, but we can send that signal from one cell tower to another cell tower over that system. The next cell tower that's closest to OB's phone will then convert that signal that came in over the wire back to a wireless signal, send that down to his phone. That signal will then get translated in his phone to some electrical pulses that vibrate the membrane of a speaker. That membrane vibrates the air, and then OB can hear those vibrations as Leia's voice asking for help. So when we're using our cell phones to communicate with each other, it's this constant process of translating our message from one type of signal to another type of signal to another type of signal without ever actually losing the data that we're trying to send. This right here is a very oversimplified version of what we're doing in data networking. Data networking does the same thing. We take messages, we encapsulate them inside of virtual envelopes, and then we send those envelopes across multiple different types of network where they get translated again and again and again. And we're going to look at that throughout this entire series of courses about all the terminology, language, protocols, and systems that are used in order to make that happen.
Okay. V5, yes. Yeah.
The CompTIA Network
We'll put
Plus
in a work
exam.
order
Here
for
we're going to take a look
ISS
at some
to
exam
look
objectives.
at
Now, if
the.
you're not studying for the Network Plus certification exam, no problem.
Thank you.
Skip to the next module. There's nothing that is important for you here. If you are studying for this, what you may want to do is go download the exam objectives at this website. You can go to certification.comptia.org/certifications/network, and that will give you a list of the certification exam objectives. This is all the details of everything covered on that exam. It is broken into 5 domains: networking fundamentals, network implementations, network operations, network security, and network troubleshooting. Now, the courses that I have designed to prepare you for the certification are generally broken up exactly into the domains that you see here, with the exception of a few topics. I took some of the information out of the networking fundamentals and I moved it into network implementations just because it fit a little bit better in there. However, it's not super important that they fit neatly into these categories. It's more how you interpret and understand this information. So I'm trying to make this as easy as possible for you to understand. So if we actually go download these objectives, it comes in this somewhat lengthy document. Here's the front page of it. They have information about the exam. And here's that list of domains that I just went over. And then they go through each domain and they break down exactly what you need to know here. And this document is very thorough, very lengthy, and it covers all of the topics that you're going to need to know about. Now, I'm not going to go through each of these exam objectives in this particular document. However, as we go through the course, you're going to learn about each one of these little snippets of information you see here. We're going to learn about all of those. It even has an acronym list at the end. There are tons of acronyms to learn in data networking. There's also hardware and software they talk about as well. So you can download this document for yourself and review it. As you're learning the exam, you can actually use this to check off the stuff that you feel like you know and the stuff that you need more help with. So let's wrap up this first module here. What I did here was define what is networking. We looked at communication processes to see how a cell phone call to our friend transfers this encoded signal of our voice across multiple different media to reach our other friend's phone. And then we looked at the CompTIA Network Plus exam objectives. We're going to go on to the next section where we look at modeling data networking so that we have a very precise system to understand the order of operations in data networks.
Hello, Victor. This is Takeda Security. My name is Carlo Navarro. I would like to report a busted sprinkler head which is leaking water all over the front of a building. So this is Takeda Pharmaceutical LA. Building 5. Los Angeles. Yes. Yes, the water sprinkler head. It's leaking a bunch of Takeda Pharmaceutical. Yes, making a big puddle into the walkway. It is 818-507-8297. Yes, I'm Takeda Security. Carlo with the Karlo and Navarro. Thank you, Victor. Did you say stay on the line or we're good? Okay. Sorry. Sorry. Yeah, I don't, no, I don't think so. It's out just outside the building, building 5. there's a curb and some plant life, and there's a sprinkler that's creating a lot of water leak. That's true. For it, whenever you're ready. Yes, you're ready. One, two, 7, 6, 3, 5. Got it. Okay. That is it. Thank you too. For the security. It's scored it out from. Okay. Yes, we'll open it for you. Are you about to leave, man? Okay. Okay. Yes, we'll open the turnstile for you. Thank you. Thank you. Thank you. What's your email? I got it. Man. Thank you. Good night. Okay, the security. Oh yes, that was us. We saw you at the gate, so that's good. Thank you very much. Thank you. Bye bye. Bye.
In this next module, we're going to be using the OSI model to describe network operations. Our goal here is going to be to introduce this OSI model to really hone in and identify the very specific components of network communication. So our goals for this module are going to be to introduce the OSI model. So let's wrap up this first module here. What I did here was define what is networking. We looked at communication processes to see how a cell phone call to our friend transfers this encoded signal of our voice across multiple different media to reach our other friend's phone. And then we looked at the CompTIA Network Plus exam objectives. We're going to go on to the next section where we look at modeling data networking so that we have a very precise system to understand the order of operations in data networks. In this next module, we're going to be using the OSI model to describe network operations. Our goal here is going to be to introduce this OSI model to really hone in and identify the very specific components of network communication. So our goals for this module are going to be to introduce the OSI model, remind ourselves about that telephone call between Leia and OB, and then use that to jump into modeling networking with the OSI model. So the OSI model stands for Open Systems Interconnect. It's a model that was developed in the 70s in order to describe network operation. Now, there's lots of different protocols involved in data networking. And what the OSI model did is it gave us a place to categorize each of these protocols, as well as give the exact order that those protocols need to be processed in. So if you remember this phone call I talked about in the previous module, the order of operations here were such that Leia had to vibrate the air, which vibrated the microphone, which converted it into electrical signals, which then got converted into wireless signals, which got converted into a different type of electrical signal, and so on until that message reached OB on the other side. Now, in order for that to happen, there is a very precise set of rules that need to happen and protocols that need to be followed in order for this conversation to successfully happen. Well, when we're working with data networking, it's almost exactly the same. We just have these different components involved versus our smartphones and our voice. We're going to be using a computer or a tablet or a smartphone, like maybe an internet browser on a smartphone, to do our communication. So let's introduce a drawing. Now, I communicate a lot in these drawings with icons, so I'll introduce the drawings and all the icons we're using so that we can use that then to talk about the OSI model. So here we have a PC. This is our end user device. Sometimes this is called a client. Sometimes it's called a workstation, PC. That's the device we're going to be using to surf the web. Now, another device in our network, especially in our home network, is likely going to be this wireless router device. And this is the icon. The purple icon here is the icon that I'm using for a wireless router. And we can then connect our PC up to that wireless router. That router typically has some switch ports on the back, so we can actually plug in a cable to that, or we might be using it as a wireless device and actually not have any cables at all and just use the wireless communication to communicate between our workstation and the wireless access point. Now, in order to get access to the internet, we need some type of device to bridge the network connection between our wireless access point and the internet. And that's where a modem comes in. So here is a modem. I showed you some real life pictures of this in the previous module. Here, this teal icon is just a representation of that cable modem or any other type of modem that's going to connect you to the internet. So we're slowly building this network up. This is a representation of your home network, right? And then out on the internet, we have a bunch of servers out on the internet, and this icon is representing the servers, the orange icon there with the globe next to it. This is going to be the servers that contain all of the information that we are going to transfer from the server to our workstation so that we can read the news, surf Facebook or other social media, or maybe check our email. For the purposes of this, I'm going to avoid the wireless for this moment. We're going to come back and talk lots more about wireless in the future. But for now, I'm just going to connect my workstation to our network with a cable. So now we have this network or this drawing of our basic network. Remember before I said that cloud represents a bunch of devices and protocols that we don't want to represent individually? And that's exactly what I'm doing here as well. That
Sure.
rest of the network, we're going to use twisted pair cabling. Connecting our cable modem to the internet might use a coax cable. And then out on the internet here, we're likely going to be using fiber optics or very thin strands of glass in order to transfer our information. So all of these cables, these different cables, whether it be wireless, twisted pair, coax, fiber optics, all of these are technology that we use in order to transfer our data from one device to another. All of this stuff is happening at what we call the physical layer of the OSI model. The physical layer is also layer 1. And the physical layer is really what we're talking about when we're talking about cables, specifications for cables, whether that be wireless, copper, or glass. The next layer of the OSI model here is going to be used to have protocols that allow us to transfer bits of information over the cables. So there is a specific protocol called Ethernet that we use to transfer data from our workstation to the wireless router, from the wireless router to the cable modem, from the cable modem to wherever our internet provider is, from the server to our switches inside of our data center, and then numerous other protocols on the internet used to transfer information. So all these little circles that I have drawn here, those are representing different protocols that could be used to transfer data. And each one of these protocols is a little bit different, but they work together all at the same level. What I have circled here, the connection between my PC and the
No problem.
router, and the
If you
cable
want to
modem
come back
and the
and see to
server and the
the
rest of the internet,
supervisor, he could
it's
probably
likely
help you out
using
with that.
Ethernet.
No problem.
The connection here between our cable modem and the rest of the internet is likely using a protocol called DOCSIS 3. Out on the internet, it's mainly Ethernet, but there could be other protocols out there. All of these protocols, Ethernet, DOCSIS, are all part of the data link layer, and they provide all of the structure to be able to use the cables that are connected to it. So they provide the protocols and the rules, specifications for electronics, as well as how to create and move a message across those links. So that's layer 2 of our OSI model, is the data link layer. So the data link layer is facilitating communication within these circles that I have drawn on the screen. It's allowing us to pass data from one device to another. However, if I want to send a message to a device that's far away, that's not on my little local network, what I need to do is I need some other mechanism to do that. So I need another type of protocol in order to do this. So I might need to communicate between my PC and my cable modem,
Take your time.
or I might need to
I'll let the
communicate from the
person know to
cable
come
modem
back.
out to the internet
You
someplace,
can take your time.
or I might need to communicate, in this case I will need to communicate from my workstation all the way to Pluralsight servers and back again. So I need some way of sending a message from my workstation to Pluralsight and then getting it back. And this is where we use a protocol called Internet Protocol, and we use something called IP addressing. The IP addressing allows us as users to communicate with nearly any device on the internet. This is where IP addressing occurs, IP routing, and it is all the network layer, which is layer 3 of our OSI model. So far we have the physical layer, our cables. We have the data link layer, which are the protocols that allow our computer and other devices to communicate locally with other devices. Then we have layer 3, the network layer. That allows us to make use of the data link layer and physical layer to send messages long distances across a network. The next layer here we're going to talk about is, in order for us to have a conversation between our client or our workstation and our server, where Pluralsight.com's website is hosted, we need a way to build a session in between these two devices so that they can send information between each other and understand that the conversation is meant for specific things in that network communication. We're going to talk lots about this process. In fact, I have a whole nother module that talks specifically about this process. But for now, let's go back to our cell phone example here where we're making a phone call. Now, we talked about kind of like the vibrating air and whatnot with this, but more so, there's another way to look at this conversation. There's another protocol we follow actually in order to make this conversation work. I can't just pick up my smartphone and start talking and expect my friend OB on the other end to listen, right? What I have to do is I have to dial a phone number for OB, and then I have to wait for OB's phone to ring. Once his phone is ringing, OB can answer that phone. He's going to say hello. Leia here says hello. And once that happens, then Leia can say, hey, I need some help. And OB can say, oh, okay. And they can have that conversation. All right. And my point here is that in order for Leia to be able to communicate with OB, we have to go through that process of dialing the phone, waiting for it to ring, waiting for OB to say hello, I say hello. And once that happens, then I can send any information I want. Transmission Control Protocol does this in data networking. This is also called TCP, and what it does is it sets up a session between our workstation and the server so that we can send data between these two devices. This is the transport layer. So the transport layer in networking is responsible for setting up a session typically using TCP. It has a handshake process and it builds a connection, and it uses the network layer to find where in the world those devices are. It uses the data link layer to communicate those messages from device to device to device to device until they reach their destinations. And that all happens on the physical layer, which is our wires and cables that connect our network together. Next, we need a way to transfer information that's in a usable format. One of those ways is to use a web browser and browse to a website like pluralsight.com and then retrieve a web page. The website is nothing more than a document with information in it. The web browser is an application that makes use of a protocol in order to request and transfer information. So in order to get the website to our workstation, we're going to make a request of the server to say, hey, send us the website. The server is going to respond with a document that is the website. And we're going to use a protocol called Hypertext Transfer Protocol. This is also known as HTTP, and it has a sibling called HTTPS, which is the encrypted version of it. Now, HTTP and HTTPS, they transfer documents that are written in a language called Hypertext Markup Language, or HTML. So we're using HTTP to transfer HTML documents. So our website is written in some form of HTML, and we use HTTP or HTTPS to transfer those. So all of this is happening outside of our process of building a session between our two workstations, or identifying the location of those devices with IP addresses, or having protocols that allow us to transfer information from our computer to the router to the cable modem, and so on. All this is happening at the application layer of the OSI model. Now, the OSI model is 7 layers, and you've noticed that I have skipped 2 of them. The OSI model was written in the 70s when they had different networking needs and other protocols involved here. So there's 2 layers that I have not talked about now, 5 and 6. So what's going on with that? Well, let's talk about it. First, let's talk about the presentation layer. Now, the presentation layer is layer 6, and we don't really use the presentation layer anymore. And there's a reason for that. Back in the 70s, there were several types of systems. There were a lot of open source systems that universities used, and then IBM had systems as well. And IBM developed very proprietary protocols that were similar but different than the ones used in university settings. So let's say we have this message of don't panic. Well, in order to create don't panic in a language that the computer understands and can encode, when we type on the keyboard, each one of these letters, capital D, lowercase o, apostrophes, and whatnot, each of those is mapped to a hexadecimal value. It's a 8-bit hexadecimal value, and it's called ASCII, ASCII, which stands for American Standard Code for Information Interchange. ASCII is still used today. When we type on our keyboard, it is still translated to these values in ASCII. So if I translate "don't panic" to ASCII, I get the D is equal to 44, lowercase o is 6F. We're going to learn about hexadecimal numbers in another couple modules here. So don't stress too much if these numbers look goofy because they have letters in them. We're going to talk about exactly why that is in a little bit. Just know that the numbers that I'm showing you here are actually numbers and not some other goofy language. So D is 44, O is 6F, N is 6E, the apostrophe is 27, T is 74, and so on. And when we put that all together, we get this string of numbers that represents "don't panic," including the space in there. In IBM land, they used a completely different number system in order to encode each key of the keyboard. So each keystroke that meant "don't panic" got encoded differently. And EBCDIC, EBCDIC, which stands for Extended Binary Coded Decimal Interchange Code, is IBM's version. It was their proprietary version. And in order for a system that used ASCII to communicate with a system that used EBCDIC, we needed some layer of the OSI model to translate from one system to the other. And that's what we intended to do with the presentation layer. Now, that has all become quite antiquated. We really don't do much with this anymore. You may find in textbooks that they're going to say, oh, JPEG and MPEG and whatnot happen at the presentation layer. That might be the case, but really those are outside of the OSI model. We're ultimately going to be using application layer protocols in order to transfer information, and we really don't worry too much about the presentation layer. The session layer is another layer. I personally don't concern myself with the session layer too much. There are some protocols that do operate at the session layer. However, for networking purposes, we don't stress too much about classifying something as a session layer protocol. Ultimately, we consider it to be part of the application layer. Let's wrap up here what we've talked about. We've introduced the OSI model. We talked about the 7 layers of it. We started by modeling that telephone call and thinking about how we had to vibrate the air and the entire process that needed to happen in order to make that phone call, as well as another idea of a protocol where we actually had to dial the phone, wait for it to ring, say hello, before we could transfer messages between the two devices. And then we talked pretty in depth about all of the components of the OSI model and how they relate to networking. So remember, the OSI model gives us a very precise order of operations that we can work with. It gives us a space to categorize each protocol so that when we are working with networking, we understand which protocols are involved and why. In this next module, we're going to take a look at encapsulation and the OSI model. Now, we just talked about the OSI model and how each of the layers have a specific purpose. Now we're going to go be a little more technical about it and introduce how those layers are being used here to send data. So our goals for this module are first to review the OSI model, then to introduce the concept of encapsulation, and then I'm going to describe encapsulation layer by layer of the OSI model. So here's our OSI model, and remember, we're going to not worry about layers 5 and 6. We're just going to stick to the application, transport, network, data link, and physical. And as a reminder here, remember the application layer. We're typically dealing with a protocol that allows us to transfer specific types of data in a specific way. Our transport layer is going to set up a session between the two endpoints, between our client and our server. The network layer is going to give us the path that we can take through the internet or through a network to get from our client to our server. The data link layer is going to let us make the individual hops between our client and our switch, the switch and the router and our cable modem, the cable modem and the internet, and so on. The data link layer is going to allow for that. And then the physical layer is going to be where we actually move the bits of information either as an electromagnetic wave in the case of wireless, or as a light signal in the case of fiber optics, or as an electrical impulse in the case of a copper wire. So let's take a look at how this happens. So if we go to pluralsight.com on our workstation, we send that information out onto the internet, and then it transfers the website to our computer. And this all seems to happen magically, seamlessly, and typically very quickly. When we're actually doing this, though, what we're going to do is we're going to take that website, and this is our actually application layer information. In the case of going to a website, we're going to use a protocol called HTTP, or Hypertext Transfer Protocol. Websites are written in a language called HTML, or Hypertext Markup Language, and we use Hypertext Transfer Protocol, HTTP, to transfer it. So this application layer protocol, HTTP, is what we're using to transfer it. When we are working with this, though, these websites tend to be quite large, so we need to be able to break up that website into smaller chunks so we can successfully get it to the client. We're going to find out at the end of this encapsulation process that some protocols, specifically Ethernet, has a maximum amount of data that we can transfer for each frame that we send. For each chunk of data that we send across the network, we have a maximum amount of data that we can send in each one. So once we have this application layer, it's going to work in conjunction with the transport layer to take that data, break it into smaller pieces, and then add it to a header. So we're going to put a header on this data at the transport layer. The transport layer, since it's setting up a session between our client and our server, we're going to have specific information in there to allow that to happen. In this case, it's a source port, a destination port number, some flags, which is just some general information about what's happening in the transaction, a sequence number, an acknowledgement number, and those keep track of how much data has been sent and received. This is kind of like if you're sending a birthday card to your dad. You would fill out the birthday card, you put any information in the card that you want, much like our website here for pluralsight.com. There's lots of websites out there, and this particular one is Pluralsight. So we can take any information we want, then we take that card and we put it inside of an envelope and we seal it up. And then we write on the envelope the destination address, which is our dad's name and address, and then we put a return address on it, which is our name and address. So we're taking this information, we're putting it inside of an envelope. This particular envelope is the transport layer, and we call this envelope a segment. So any data that we have with a header at the transport layer, we call a segment. So a chunk of data with the transport layer header is a segment. This particular segment header, or transport layer header, is a TCP header. And we're going to learn more about TCP in another module in this course. For now, we just need to know that this information allows the client and the server to set up a session and keep track of what data has been sent and received. Now, that's just one component of this transaction. In order to know where we are sending this data, we need to tell it what the source and destination IP addresses are. So we need to know where on the internet or on a network the server and the client are. So we take our transport layer information, which is going to keep that session between our endpoints going, and then we send it down to the network layer. So we take our segment and it becomes the payload of our network layer. And then we add this header. We add the source IP, destination IP, a value called the TTL, or time to live, which tells it how far this packet can travel at a maximum distance, as well as some other information that we add into the network layer header to make this transaction work correctly. I don't go into too much detail on that because it's not important at this level of understanding of data networking. So now we have our segment inside of the payload of our network layer header. This is called a packet. So anytime we have some data that we're transferring with a network layer header, this is a packet. So it's a chunk of data with a network layer header. This particular one is an IP header, or Internet Protocol, specifically Internet Protocol version 4. And we're going to learn more about IP as we go throughout this course and throughout the series of courses that will help train you to get a better understanding of data networking. So our network layer header is going to allow us to know what two endpoints on the internet or any network we're going to send this information to. Now, in order to get our packet to go from one device to the next, right, from our workstation to the switch, from the switch to the router, from the router to the cable modem, from the cable modem out to the internet, and all of the hops that go along the internet, we're going to need a data link layer header here. So we send our network layer packet down to the data link layer, and we put it in a frame. Now, a frame is just a chunk of data with a data link layer header. In this particular case, this is an Ethernet header. So this is going to be an Ethernet frame. And we'll often use the Ethernet frame when we're sending data from our workstation to the switch, from the switch to our router, from a router to the cable modem. However, once we get to the cable modem, we're going to use a different protocol there, which requires a different frame. So what we'll end up doing is taking the packet out of the frame and putting it into a new frame. And this happens consistently throughout the transaction as we're moving the data across the internet. The packet will remain the same. The frame header will change as it goes from segment to segment to segment. Now, in our frame, especially an Ethernet frame, remember earlier I said that there's a maximum amount of data that we can send in that? So here our data is still intact here. That chunk of website that we're sending is still encapsulated inside of this frame. There's also a transport layer header, there's a network layer header, and then we have this Ethernet header. When we're working with this, especially Ethernet, the data part of this can have something called a maximum transmission unit for Ethernet, or MTU. And for Ethernet, that's typically 1,500 bytes. We can make that larger in some cases, but in most cases, 1,500 bytes is the maximum amount of payload, including the packet header, including the segment header, that we can send using an Ethernet frame. So we have to break up the data into these smaller chunks to allow this to happen. And like I've mentioned, we can make that larger in some cases. Lots of times inside of a data center, for specific applications, we will increase that MTU size. But for regular day-to-day use on our networks from our PCs, we rarely adjust that size. Once we have our frame constructed with the source MAC address, destination MAC address, and then layer 3 protocol that we're using, we can then take that frame, send it down to the physical layer. And when we send it down to the physical layer, what's going to happen here is we're going to convert that into ones and zeros, and then the ones and zeros are converted into a signal. That signal could be a light signal that we send across fiber optics. It could be an electrical pulse that we send across a copper wire, or it might be an electromagnetic signal that we send with wireless. So in order for us to get the website from Pluralsight over to our workstation, we have to send all that data up and down the OSI model in order to make all the hops that we need to make in order to get it from our server over to our workstation. And that involves taking our application layer information, putting it inside of a segment, taking the segment, putting it inside of a packet, taking the packet, putting it inside of a frame, and then sending it across the wire. So to wrap up this discussion about the OSI model and encapsulation, we first reviewed the OSI model. We then introduced this concept of encapsulation, like taking a birthday card and putting it inside of an envelope. However, in this case, we're taking that birthday card, putting it in an envelope, putting that envelope inside of another envelope, putting that envelope inside of another envelope before we put it in the mail. I described the encapsulation concept layer by layer of the OSI model, and we introduced the concept of segment at the transport layer, packet at the network layer, and frame at the data link layer. I hope this was useful. This is literally the foundation of everything else we are going to discuss in data networking. So I hope you found this useful. Let's move on to the next module where we start to talk about protocols more. In this next module, we're going to look at protocols and port numbers for those protocols. And we're specifically looking at application layer protocols. And in our goals for this module, we're going to look at numerous application layer protocols. This can get a little bit tedious, but I have broken it up with a couple demos, and we're going to try to make it as interesting as possible. So we're going to start with data transfer protocols. Now, almost everything in data networking is moving data from one device to another. However, there are some that meet this criteria more than others because we're actually moving a file that we're using as users versus doing some kind of network